All right, this is intensity of light and moving air, part of the influences of weather and climate. This is Explore 1. So I'm going to show you part 1 for this activity. There's quite a bit of instructions, which I have also posted in Google Classroom, so you can follow along. And after you've the part with the instructions, there's a few questions to answer, so make sure that you fill in those blanks. I'm going to follow these instructions exactly as we go. So you can see, and if you would like to or are able to, you can replicate at home so you can kind of see how it works. This is something we would normally do in class. Unfortunately, that's not an option. So we're going to do a demonstration and then you can answer questions. And if you have the materials, you're welcome to try it at home as well. So the first part says 90-degree angle, and we're looking at how intense, meaning like how concentrated the light is on Earth in different areas. So the first part says label a piece of graph paper at 90-degree angle. So I have done that here. So we have a piece of graph paper, and then it says to tape it to a piece of cardboard. That is done. Then it says place a flashlight on a book so that it is horizontal and level. Tape it in place with a piece of masking tape. So I have done that. I used a cinnamon roll box instead of a book though. So you got to use what you have handy. Then in step 3, it says place a metric ruler flat next to the flashlight. So the end of the metric ruler extends 3 centimeters beyond the end of the flashlight's beam. And then it shows you what that should look like here. So I have that as well, 3 centimeters. And then it says to hold the paper and the cardboard at the end of that 3 centimeters at a steady distance. And to make sure it's at 90 degrees, ideally we would have a protractor to be able to see that this is in fact a 90-degree angle. I'm going to do my best to estimate because I don't have one handy. And then I'm going to outline that circle on the paper, and then we will count the number of squares inside that circle. So after counting the number of squares inside the circle that I outlined, and that's exactly where the flashlight hit. The ones that were just like barely a corner I didn't count, but we had 256 is the count of squares inside on this graph paper. So now we're going to do it at 70 degrees. So we'll do the same thing, except I will have, instead of having it at 90 degrees, we're going to move the paper. So instead of at 90 where I had it before, we're going to move it so that's a little bit of an angle, and you'll notice exactly when I move it how the light kind of extends beyond. And now I'm going to trace that circle and count those squares. So when we have it at the 70-degree angle, which is the one I've outlined in green, we have a total of it lighting up about 422 squares. But when we have it at 90, it was 256. So we can kind of see how it highlights way more of the paper when it's at a 70-degree angle. So now we're going to be looking at, so the next part is with a globe. So I have this inflatable globe, and we're going to, says next step 12 says remove the flashlight and ruler from the textbook. So we're going to take this off here and place an inflatable globe on the surface so that the equator is horizontal and parallel. So the equator is the line that goes directly around the middle. So here we have, there's Asia, Africa, you can see there's the US, and the equator is down here, right here. So we have that going all the way around the middle, and we want that to be parallel and horizontal, so meaning it's this way with our surface. Then it says to have one group member hold the globe in place for the rest of the activity. Working solo, so we'll get it to be as parallel as possible. Then turn on the flashlight and hold it horizontal and parallel to the work surface. So put that about here. So horizontal and parallel would be right about here to that work surface. And then it says to point it directly at the equator, and the globe surface and the metric ruler must touch. So I still need it 3 centimeters away, just like it was before. So at 3 centimeters, so if I put the flashlight 3 centimeters away right at the equator, you can see the shape that it makes on the globe, and it looks very round. More like when we were holding it at the paper at 90 degrees. So then the next step says to compare the general light shape of the main beam to the 2 shapes previously outlined. So it should look more similar to the one at 90 degrees. And then step 16 says to repeat, but this time point the flashlight directly at the Tropic of Capricorn. And that is the one down here, or the Tropic of Cancer, and that's the one up here. So these are those 2 lines that go around this way. So we're looking at it flat, and we're pointing at the Tropic of Cancer, which goes through Mexico, and we're going to do that here. Then you can see that the top part of the light kind of extends beyond, and is no longer just round, but it kind of goes above into the top of the globe, and it has more of the shape, just like when we were at that 70 degree on the graph paper. So now, having done this part 1, you're going to go through and answer the questions in your assignment. So make sure to scroll to the part where there's questions and fill in each of those blanks. If questions come up as you're working, as always, make sure you're emailing Mr. Olson or I. So this is part 2 of the Explore 1 for influences of weather and climate. So part 2 is about moving air. So it says step 1, work in pairs with your group. So I have a partner here, and we inflated and tied off a round balloon. Instead of a balloon, we are going to be using our inflatable globe again. And then step 3 says to use a marker to draw an equator line around the middle. And ours already has that. That's this line right here. And then it says to step 4, on the top of the balloon, draw a small arrow pointing from west to east. So we have an arrow going in that direction. And then one person must hold the balloon and slowly rotate it in a counterclockwise direction. So following that arrow. And then since the air falls at the North Pole, which means as it gets colder, it starts to sink. Remember those convection currents. And have a second person place a marker at or near the North Pole. And draw a straight line to the equator as the balloon is rotating. This line is representing the air moving down from the North Pole towards the equator. So we're going to slowly be drawing this line down as it's rotating. And so this line, even though I was drawing just straight down, ended up curving in this direction towards the equator. And then we're going to switch roles, says, but I'm going to still not switch roles. Then we're going to begin rotating the balloon again in the same direction. This time we're going to draw the line beginning at the South Pole and ending at the equator. So from where it also the air sinks at the South Pole towards the north, do not flip the balloon over. This line will represent the air moving from South Pole towards the equator. So I'm going to draw my line. So this line, as I draw it up, goes in this direction. And the one up here went in this direction. So you can see on this balloon, the one's from the north goes here and south goes there as the earth is spinning. So now you're going to draw a diagram of this model and then answer the questions on the next page. It says also ask about how is wind formed. So recall from our last unit about differences in air temperatures and how that might cause differences in air pressure. And then explain what this activity is modeling and how you think the Earth's rotation changes the direction of wind on Earth. So remember that vocab word, global winds. That's my hint to you.